So we have understood that the direct rays of the sun between the Tropic of Cancer and the Tropic of Capricorn make it as a positive energy region, and the moment we start moving from the equator towards the pole, we get more the cold cool temperature, and that is the energy deficit area, so it becomes a negative energy region. Now we will focus on the radiation, on the solar radiation, and the various ways to measure the solar radiations. Before we go to that, we have to study the three pathways of energy, that is the three ways by which energy will travel. First is the conduction, which is the linear motion of energy. Convection, which is the vertical motion of energy, and advection, which is the horizontal motion of energy. Now, starting with conduction is relatively simple. What happens here is, like for example, this iron rod, which is having molecules right adjacent to each other, and if I'm providing heat at one end of the iron rod, the molecules will start vibrating one molecule to another molecule and to the whole iron rod. And the thing what happens when you touches a hot utensil which is placed on a hot gas, you feel out. So that is the conduction. It is simple linear motion of energy. Then we talk about convection, and this convection in this utensil, we can see this flame, this warming we are providing from the below. And what happens is the water which is above this hot gas, it is getting less dense, and with less dense, it start rising up and slowly cooling off, and then it starts sinking. So this whole convection, which is the vertical motion of the energy, it works with different densities. So the water which is getting less dense, it is rising up, and then the cool water which is more dense, it is sinking down. So it becomes a cycle, and very important to understand, because this is what is happening in our environment as well. So less dense rises, more dense sinks. So here we can see this is a flame of light which is there on the water utensil. Water is getting heated, and once it is getting heated, it is becoming less dense, so it will rise. Gradually it will cool off, and then it will sink. After cooling off, it will become more dense, and then it will sink again. Then again the whole process will start. So rising and sinking. Less dense, rise. More dense, cooling, then it will sink. So rise and sink, rise and sink. Which is the vertical motion of energy. Convection is the vertical motion of energy. Then we comes to advection, which is the horizontal energy movement or horizontal energy transport. Let's understand it with an analogy. So here we have a bathtub which is full of cold water. Here you have a tap which is giving cold water, which is giving hot water, and this is cold water. Now what will happen is, the moment now hot water will start pouring into the tub, so it will start making this part of the tub as hot. But what about this part? It is still cold. So what will happen is, slowly after some time, this hot water will transport itself to the cold water region, and slowly we will see the whole bathtub water becomes hot. So this is the horizontal motion of energy, and this is called advection. So we see three basic things. One is conduction, second is convection, which is the upper motion. We saw utensils, we are getting it warm from the bottom, and it is getting less dense, it is rising up. So rising up and then sinking. After cooling off, it is sinking. So rising and sinking, we link it with convection, that is the vertical motion. Then we talked about the advection, which is the horizontal motion of energy. Same thing happens with the Earth's surface also, where we see warm air and cold air getting collided. The motion of the warm air towards the cold air or vice versa. Now let's start with measuring radiation. There are three basic parameters through which we measure radiation, and first is the wavelength. So let us see what wavelength means. So this is my wave and the distance between the two crusts or two troughs. So it is the distance between the two crusts or either two troughs. So this is wavelength. Now we'll draw two wavelengths. So out of these, which one is short wave and which one is long wave? So it is very easy for me. This distance is less and this distance is more. So this becomes long wave and this becomes short wave. Right. This becomes short wave and this becomes long wave. Now I ask another question, right? So this is 1 and this is 2 wavelength. So which one is more powerful? Now this wave, short wave or long wave, which is going to be more powerful wave, which is going to be more powerful wave? So answer is simple. Again, the short wave is going to be more powerful because it is getting more number of troughs, so it can push more number of crusts and troughs in a particular time. So it is more powerful, it is having more energy, it can bring with itself more energy because more number of troughs, more number of crests. And long waves, it is going to be a less powerful wave. Less powerful wave. So we understood one thing, the concept of short wave and long wave. Short waves are powerful and long waves are less powerful. Second is amplitude. Amplitude is easy for us. So this is the wave and this is the midline. So distance from the midline to the top of crest, it becomes amplitude. Similarly, we have frequency. So if this is a particular point A, so the number of times the crest will pass this particular point, it would become the frequency of that wave. So now if I say this is A and this is B, which is having higher frequency, so A is having higher frequency, is B is having less frequency, because less number of times these troughs or these crests are passing to a particular point. So we have understood the three ways of energy transport: the conduction, the convection, the vertical motion, advection, the horizontal motion. We saw it with the analogy of a bathtub. Then three ways of measuring radiation, which is the wavelength, amplitude and frequency. And now let us put all these things together and how it works, and then we will classify them using the electromagnetic spectrum like this. So here the electromagnetic spectrum, all radiations are labeled from the shorter wavelength to the longer wavelength. So here we can see this electromagnetic spectrum, which is starting from the short wave, right? The short wave, which is the powerful wave or the wave which is having a higher energy. So that becomes very important for us to understand. Now the short waves are the powerful waves. These waves have high energy. So from gamma rays, then to X-rays, then ultraviolet rays, then visible band, then infrared, microwave and the radio waves. So we see here the wavelength is decreasing, or wavelength, it is becoming longer, the longer wavelength, and it is getting lower energy. So longer wavelength will have less energy or less power than the shorter wavelength. So gamma rays, X-rays, ultraviolet, visible band, infrared, microwave, then radio waves. So wavelength is inversely proportional to the frequency. So the more the frequency is, less would be the wavelength. Let's move now. We have seen the short waves and the long waves. Now we will see how radiations get altered. How this short wave is going to change into long waves and what effect it will have on our environment. So when we go from short wave to long wave, something happens in between that changes that radiation from a very short wave to a long wave. That is from a powerful wave to a weak wave. So we have to have a process, and that process is known as absorption. Absorption. So energy is absorbed. So it is changed. So if we go from short wave to long wave, we must have absorption. That is, in other words, like we can say from a powerful wave, if we are going to get a less powerful wave, we need to get that radiations absorbed somewhere. So let's do an example. Let's see an example to see and illustrate this particular thing. We have two players, right, and they're having a ball with them. So when this player A to player B, it is giving directly this ball to player B. So there's no loss of energy with the ball. So this becomes the short wave. They are directly transferring the ball from A to B. Now what happens in second situation, this player A and player B, this player A throw the ball on the ground, and after one bounce it is coming to player B. So now what happened is, when he threw the ball on the ground, there is some absorption of energy for that ball, and the ball now which is getting to B, it is getting less powerful, or it is getting with less velocity or energy. So this is absorption. And this is the long wave. From short wave, from higher energy wave, we are getting a less energy wave or long wave. Now we remove this possibility. We are having only player A who is playing alone, and he don't have anyone to play with him. So this is a surface. Now he threw this ball. So every time this ball will jump on the surface, its height, bounce height, will keep reducing. So what it means is, every time it is getting bounce, it is losing some energy. So it is, and finally it is going with the flow. So every time it is getting absorbed, some of the energy getting absorbed. So from short wave to long waves to less powerful waves, and then it is diminishing. So this is a concept from short wave to long wave, or from a more powerful wave to a less powerful wave through absorption. So when we have absorption, we are getting an output of long wave or less powerful wave. Now let's compare this with a greenhouse effect model. So here you suppose you have a greenhouse, right? So here you have insolation. Insolation means direct rays of the sun. So sun is sending its wave, which is a short wave, right? Which is a very powerful wave, and this is a house made up of glass. So we have a greenhouse and we have solar radiation, and solar radiations come in as the short wave. Short wave as a powerful wave, and we call it as insolation. Let me write it down. So insolation, that is the radiations from the sun, the short waves. Then it gets absorbed, right? So it reaches the surface, it is getting absorbed here, and in turn it will transmit the less powerful long waves, right? So again, these long waves, it will get trapped in between this, and slowly, if you remove this box, it will get diminished. So this is the same principle when we saw this player. He dropped a ball on the floor, and slowly, from long waves, then the more less powerful waves, then much longer waves, and finally it is getting diminished. So same thing happened with the greenhouse model as well. So short wave to long wave, and through the process of absorption, the energy is getting absorbed. So powerful, the short waves getting less powerful. So similarly, here we can see the example: insolation getting the direct rays of the sun as a short wave, and this particle is absorbing the energy and then transmitting the long waves. So if we see a radiation cycle, a typical radiation cycle, so it starts from insolation. That is a short wave, incoming short powerful waves. Then we have absorption, then we have long wave emission, which are less powerful waves, and then finally we see dissipation. So this is a radiation cycle. Now opposite to absorption, right, we have reflectance, and that is known as the albedo. So it is the opposite of reflection, or it is the opposite of absorption, and it is the reflectance value of an object. What it means simply is how much energy is reflected by an object. So how much light which is falling on an object, how much it can reflect, that will be the opposite of how much it will absorb, right? So albedo, it is the opposite of absorption, which means the absorption is opposite to reflectance. We can see this example here, this ice, okay, for example this snow is having high albedo. So what it means is that whatever light it is getting on the surface, it is reflecting it back. Similarly, the object with a low albedo, that is the low reflectance, it is getting most of the light getting absorbed, and the less reflectance. So the less absorption or high albedo would result in low temperature. It makes sense. High absorption and low reflectance would result in high temperature. So we get now temperature is a result of how much radiation is getting absorbed in the surface. So snow is cold. What makes it cool is the high albedo value what snow has, right? So when you move on the snow, like, you need sunglasses with you, because the light which is getting reflected from the snow, it makes you blind, you cannot walk. So that is a high albedo, the high reflectance value, and the low absorption of the ice, which makes it cool. On the other side, when we see asphalt or the other black substances which has low albedo and high absorption, so these two are the opposite things, reflection and absorption. So now the substances which is having high absorption and low albedo, that is the low reflection, you are getting to have high temperature. So it becomes really important now to relate these facts. So for example, snow which is having high albedo, it would have low temperature. Similarly, a material like asphalt which is having low albedo, that is low reflectance but high absorption, it is going to have high temperature. So high temperature is a result of low albedo and high absorption. So it becomes A very important basis for us. So starting from the radiations, we saw how you will classify between a less powerful or more powerful wave. We saw like if it is a short wave with more number of crest and trough, right? So it will be a powerful wave. It will carry more energy with itself. And for the long wave, it would be a less powerful wave. Then we saw how this radiations will alter, like from a short wave or more powerful wave, how it will become a less powerful wave or a long wave, and it will be through absorption. We saw an analogy of two players playing with a ball, where every time the ball bounces on the floor, its energy gets absorbed and the result would be the less energy output. Now opposite of this absorption, it becomes the reflectance, okay, and we call it albedo. Albedo. Snow is having a high albedo, that means it is having high reflectance value. So whatever light would fall on snow, most of it will reflect. So less absorption, it will result in low temperatures. Opposite of that, the substances which would have low albedo, that is low reflectance and high absorption, they would tend to have high temperatures.